Alright, so welcome back to PMT 002. So today we're going to start the second half of your syllabus, which is probability. Okay, so this is just an introduction to probability. So this chapter should be fairly easy for you to go through. Okay, it is just an introduction. So let's look at your learning outcome. So basically here we will introduce probabilities to you. Okay, and then you will learn how to see the probability of an event, how to calculate the probability. And this one is types of events. This I will go through briefly, but we will actually be repeating this in the next chapter. Okay, basically in chapter 7 and chapter 8. So that is where it's a bit more important. So I will just go through briefly, but as we go along later, I will go through the meaning again later. Okay. Notations and definition. That means, what does the notation mean? How do you see a union sign? How do you see intersection sign? Yeah, I'll go through that. And the complementary event law. This will be the first law that you will be learning. Okay, so let's look at probability. So if you're looking at your manual, we are basically here doing this part right now, all right? Okay, so what is probability? The possibility of something happening or the likelihood of it happening. So if I say it's a high probability or high chances that it's going to happen, so you're talking about the probability that goes close to 1, all right? So 0 means it's impossible, 1 it will surely happen. So as you move closer towards 1, the probability of it happening gets higher and higher and higher. Okay, so look at this. When you actually flip a coin, the probability of getting a head or a tail, that's an even chance. Why even chance? Half and half. Either you get a head or a tail. All right? Okay, so impossible. When you roll two dice. All right, so you're rolling, what's the probability of getting a 14? Impossible. You cannot, because the highest is 12, right? Okay, what's the probability that the sun will rise? Surely the sun will rise. The probability will be 1. Okay, so as you go from impossible towards 1, as you're moving, the probability of the event happening gets higher and higher and higher. Okay, you can write your probability in percentage, decimals, or fractions. But if it's in fractions, it must always be in the lowest form. Okay, most of the time I always advise students, if the question is giving you in fraction, you answer in fraction. If they give you in decimals, then you put it in decimals. If decimals, it will be in 4 decimal places. All right. Okay, next on. How do you calculate the probability of an event happening? Okay, you look at the event over the sample space. I'll show you in a bit. Okay, a spinner has 4 equal sectors colored yellow, blue, and green and red. Okay, what are the chances of landing a blue after spinning the spinner? So what's happening here? You're spinning the spinner. That's the experiment. What's the possible results? You have 4. What's the probability of landing on a blue? 1 out of 4. Okay, so this shouldn't really be an issue. It should be okay. So if you're going back to your manual, I'm actually right here. Okay, I'm right there. So now we will be looking at types of event. This is what I told you. You'll be repeating this again actually. All right. Just give me a minute. Okay, so types of event. There are 5 types of event that you need to know for your syllabus. First one being mutually exclusive. What is mutually exclusive? When 2 things cannot happen at the same time. Okay, 2 events won't happen at the same time. Like when you toss a coin, can you get head and tail at the same time? No, it's either you get a head or you get a tail. So this is what you call a mutually exclusive event. When 2 events cannot happen at the same time. It simply means whatever it means. It is mutually exclusive to itself. Okay, that means it cannot happen together. Okay, when you toss a die, 3 and 6 cannot happen at the same time. Why? You're tossing one die, right? It's either you get a 3 or you get a 6. You cannot get 3 and 6 at the same time because you're talking about one dice. All right? So that is mutually exclusive. All right? This gets important because they always test you in your exams. Sometimes they test you the theory of it. They just want to know whether you know what it means. Sometimes they ask you to prove it using formulas. So that we will go do it as we go along in chapter 7 and 8. So non-mutually exclusive simply means whatever the opposite of this. That means the event can happen together. Okay, when you toss a die, even number and 6 can happen at the same time, right? When I roll the dice, I can get an even number because 6 is an even number. So if I get a 6, and it is an even number, so it can happen at the same time. All right. Okay, independent event simply means whatever it means. One event doesn't affect the other. They are independent to each other. All right, that is what you call an independent event. Choosing your breakfast does not affect the location you sit in. Okay, so the meal and seat are independent events. All right. Okay, so whether it's sunny today and you turning up to college, it's independent actually. Okay, because it is a sunny day, but you need to turn up to college. All right, so event 1 and event 2 are independent of each other. Okay, and then you have dependent event. What is a dependent event? When one event is affected by the other. The priority of a car owner being able to drive to work in his car is dependent on him being able to start the car. If you cannot start the car, you can't drive the car. So these are dependent events, when one event affects the other event. Okay, complementary event is an event that either occurs or it does not occur. For an example, okay, for an event of choosing coffee for breakfast, the complementary of it is not choosing coffee. So probability of me choosing coffee plus the probability of me not choosing coffee, the total should be 1. That is complementary event. So these are the 5 events that are important. All right. So let's look at the complementary event. So this is your slides and I'm here in your manual. So I'll just use your manual because the slides are pretty close to it. Okay. So probability of A happening plus the probability of A not happening is 1. All right. So if the probability of getting coffee for breakfast is 0.7, then the probability of not getting coffee should be 0.3. Okay. If the probability of getting a sandwich for breakfast is 0.6, then what is the probability of getting scrambled eggs? Is it 0.4? No, it is not 0.4. The probability of getting sandwich for breakfast is 0.6. Not getting sandwich is 0.4. The probability of getting scrambled eggs is unknown. Okay, when you have complementary events, all right, you must, so basically this is the slide. You may want to write down a note here. Okay, it is not known. All right, the probability of you getting a scrambled egg is not known. When you talk about complementary events, you must be talking about the same thing. That means the probability of getting a sandwich and not getting a sandwich. Okay. The probability of getting a 5 on a die is 1/6. What's the probability of not getting a 5? This is known probability, so 5/6. What is the probability of getting a 4? 1/6. This one you know the probability, like this you don't know. This event is a known event, so you know. Okay, the probability that it will rain today is 0.3. What's the probability it will not rain today? 0.7. What's the probability that it will be cloudy? Not known. You don't know what's the probability it will be cloudy, all right? Okay. The probability of taking the bus today is 0.3. What's the probability of taking the taxi? Not known. You don't know. Probability of not taking the bus, that you know. That's a complementary event, so 0.7. Probability of taking the train? You don't know. Okay, a spinner has 4 equal sectors. What is the probability of it not landing on a red? So what's the probability of landing on a red? 1/4. What's the probability of not landing on a red? 3/4. Okay, so let's try this. Find the complement of each event. So rolling a die and getting a 4. So when you roll a die, what's the probability of getting a 4? Okay, so you want the probability of not getting a 4. Rolling a die and getting a 4, the probability is basically 1/6. So what's the probability of not getting a 4? 5/6. All right. Selecting a letter of the alphabet and getting a vowel. So you want a complement of it. That means not getting a vowel. How many vowels do you have? A, E, I, O, U, which is 5. So the probability of getting a vowel is 5/26. What's the probability of not getting a vowel? 21/26. All right. Selecting a month and getting a month that begins with a J. So you want the complementary of it is not beginning with a J. So how many begins with a J? January, June, July. So 3/12 begins with a J. How many doesn't? 9/12. So I already told you that you must give your answer in the lowest form. So your lowest form will be 3/4. Selecting a day of the week and getting a weekday. How many weekdays you have? 5. So not a weekday, 2/7. Okay, complementary events are events that are just the opposite of it. Exactly the opposite of it. Okay, so let's try exercise 6.1 now. A single letter is chosen at random from the alphabet. What is the probability that it is a B? 1 out of 26. X, 1 out of 26. Vowel, you have 5 vowels out of 26. A 5, the probability of getting a 5, 0. P or a Q, 2 out of 26. Total will be 1 out of 13. What is the probability? Is not a vowel. So a vowel is 5 out of 26. Not a vowel, 21 out of 26. Always remember to put your answers in the lowest form. Okay, next one. 6.1, number 2. They've given you some numbers here. A digit is selected at random from S. Determine that it is a 6. So 6 is 1 out of 10. You have 10 numbers here, right? Greater than 6. When you say greater than 6, 6 not included. So 7, 8, 9. That is 3 out of 10. Odd number. How many odd numbers? 0 got no values. So 0 is neither odd, neither even number. So 1, 2, 3, 4, 5. You have 5 odd numbers. 5 out of 10, 1 over 2. 5 or 1 or 8. When you see or, you need to add up the probabilities. Alright, you see or, you need to add up the probabilities. Okay, so 5 or 1 or 8, it is 3 out of 10. Okay, you add up because what's probably getting 5? 1 out of 10 plus 1 out of 10 plus 1 out of 10, that's 3 out of 10. What's the probability of not getting a 6? The complement of this is getting a 6 is 1 out of 10. Not getting a 6 is 9 out of 10. Okay, a spinner divided into equilateral sectors. The pointer is spun. What is the probability it comes to rest on 10? 1 out of 6. What's the probability it rests on 1? 2 out of 6. Why 2? You have two equal sectors here. So 1 out of 3. A number greater than 5. Greater than 5, 5 not included. So you have 9 and 10. 2 out of 6, 1 over 3. Okay, so you have a roulette wheel with 37 numbers. The 0 is green. Half of the other numbers. So basically, you have 36 left, right? 18 are red and 18 are black. Small ball is thrown. What is the probability you get a 24? What's the probability you will land on a 24? 1 out of 37. What's the probability it will be red? 18 out of 37. Okay, because you have 18 red numbers. Not 24, complement of each other, 36 over 37. Not a red, the complement of this, 19 out of 37. Okay. Alright, so this is probably just matching it only. The probability that your next flat tire will be in the front. So either it's front or back, right? So it's half. The probability that Elvis Presley is alive is 0. It can't happen because he's already dead. The probability that it will rain in Perth next year, yeah, surely in that whole year, one day it will rain. Alright, so the answer is 1. The probability that a peacock lays an egg, it will be 0. Peacock is male. A peacock cannot lay eggs. Peahen lays an egg. So it's 0. The probability that a man aged 45 will live to 46, meaning the probability that he will live to the next year. The probability of living is high, but you cannot say for sure. Why you cannot say for sure? Because what if he crosses the road and meets with an accident? The probability of living is high, but there is also a small chances he may die. Okay, so these numbers are not, you can't use. Why? You can't have a probability more than 1, and you can't have a probability that is negative. Alright, so right now let's just look at the manual. Where are we? We are here. So we're going to complete question 6 and 7 now. Alright, so question 6, there are 20 cups in the cupboard. Some are white and others are pink. Find the probability that a randomly selected cup is white. Is 0.75. How many are there? Pink cups. So if white is 0.75, pink should be 0.25. Correct or not? Total probability is always 1. Then you can know that out of that 0.25, out of the 20 cups, you just multiply, you will get 5 cups. It's pretty direct. Okay, a chessboard has 64 small squares. So if you look in your manual, I've not given you a chessboard here. So maybe you want to refer to this. So this is your chessboard. A square is selected at random. Determine the probability that it is blank. So it will be half. So even if you calculate, out of that, half of the 64 is actually blank. In a corner, which is corner? These are corners. 1, 2, 3, 4. So you have 4 corners, 4 out of 64, 1 out of 16. Along an edge, what is edge all around here? So you calculate, but make sure you don't double count. Huh? Here you have 8, then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 20, 28. So basically, if you count, yeah, I counted this already, so 28 stops here. So you count everything all around, it will be 28 out of 64, which is 7 out of 16. One of the main diagonal. What is diagonal? This is diagonal. Okay, so you count 1, 2, 3, 4, 5, 6, 7, 8. Then one more diagonal here. 1, 2, 3, 4, 5, 6, 7, 8. So 16 out of main diagonal. You don't calculate all the main diagonal is just the two main ones, the ones in the middle. So 16 out of 64, you get 1 out of 4. Not along an edge. That will be the complement of this. So along an edge is 7 over 16. Not along an edge is 9 over 16. Not in a corner. If in a corner is 1 over 16, not in a corner is 15 over 16. All right. So that's about it for the introduction. So it's pretty much, today we will just complete exercise 6.1. All right, so pretty much quite direct. All right, so I'll just go through the manual and see if we have not left out. Let me see. Yep, we are pretty much covered with chapter 6. All right, so we will stop here. Once you're done, upload your work. Any questions, please ask. All right.